Hey everyone, and welcome back to the channel. If you've ever gazed up at the night sky, mesmerized by those tiny, glittering specks of light, you've probably asked yourself, why do stars twinkle? It's one of those classic questions, a beautiful mystery that has captured human imagination for centuries. Today, we are going to dive deep into the science behind this celestial dance and uncover the real reason our stellar neighbors appear to shimmer and shift right before our eyes. So, let's get straight to it. The short answer is, it's not actually the stars themselves twinkling. Mind-blowing, right? Stars, in reality, shine with a steady, constant light. The twinkling effect, what scientists call astronomical scintillation, happens right here on Earth, specifically within our planet's atmosphere. Imagine trying to see a light at the bottom of a swimming pool from above. The water, constantly moving and swirling, would distort the light, making it appear to dance. Our atmosphere works in a very similar way. Our atmosphere isn't just one smooth, uniform blanket of air. Oh no! It's a dynamic, ever-changing ocean of gases. We have layers of air with different temperatures, densities, and pressures, all constantly moving, mixing, and shifting due to winds and heat. Think of it like a giant, invisible cosmic filter that the starlight has to pass through before it reaches your eyes. When light from a distant star travels trillions of miles through the vacuum of space, it arrives at the edge of Earth's atmosphere as a perfectly steady, focused beam. But then, it hits our turbulent atmosphere. As this beam of light passes through these different pockets of air, some warmer, some cooler, some denser, some less dense, it gets refracted, or bent, ever so slightly. Each pocket acts like a tiny, imperfect lens, nudging the light in a slightly different direction. Now, because our atmosphere is constantly in motion, these pockets of air are also constantly moving. So, the starlight isn't just bent once. It's bent again and again, over and over, along its journey to your eye. The result is that the path of the starlight is continuously changing. One moment, a little more light might reach your eye, and the next, a little less, or it might be shifted just a tiny fraction of an angle. This rapid, fluctuating change in the amount of light and its precise arrival point is what we perceive as twinkling. It's like the star is winking at us, hundreds of times a second. You might have also noticed that stars near the horizon seem to twinkle a lot more dramatically than stars directly overhead. There's a simple reason for this too. When you look at a star closer to the horizon, its light has to travel through a much thicker and often more turbulent section of our atmosphere. It has more atmospheric stuff to fight its way through, meaning more opportunities for refraction and distortion. On the other hand, light from a star directly above you travels through the least amount of atmosphere, so it experiences less interference, resulting in less noticeable twinkling. It's a bit like looking through a thicker window pane versus a thinner one. The thicker one often has more imperfections to distort your view. So, if stars twinkle because of our atmosphere, what about planets? Have you ever noticed that planets usually shine with a much steadier glow, without the dramatic twinkle? This is another fantastic observation that helps prove our atmospheric theory. Planets, like Venus or Jupiter, are much closer to us than stars. Even though they appear as tiny points of light to our naked eye, through a telescope, you can see them as small disks. Because planets are so much closer, their light reaches us not as a single, tiny point, but as a small collection of parallel light rays, effectively a larger disk of light. When this disk of planetary light passes through our turbulent atmosphere, different parts of that disk are refracted in different directions. But because the light source is larger, the overall effect of the twinkling gets averaged out. Imagine 100 tiny lights twinkling independently. Overall, the combined light source appears much steadier. So, while individual rays from the planet are still being bent, enough of them reach your eye that the light source as a whole appears to shine steadily, without the dramatic flicker of a distant star. It's truly a beautiful demonstration of how distance affects our perception. This phenomenon of twinkling is also why professional observatories, those giant telescopes, are often built on high mountains in very dry climates. By placing them high up, they are literally above a significant portion of the Earth's atmosphere, especially the denser, more turbulent lower layers. This minimizes atmospheric distortion, allowing them to capture clearer, more stable images of distant celestial objects. And even then, modern observatories use incredibly advanced technology called adaptive optics, which can actively measure atmospheric distortions and correct for them in real time, essentially untwinkling the stars for scientific observation. It's a marvel of engineering that allows us to see the cosmos with unprecedented clarity. So, the next time you look up and see those beautiful twinkling stars, you'll know it's not the stars themselves doing a cosmic dance. Instead, it's our very own atmosphere, a dynamic and invisible ocean of air, playing tricks with the starlight, creating that magical, shimmering effect. It's a wonderful reminder that there's always more than meets the eye, even in the seemingly simple beauty of the night sky. Isn't science incredible? It takes something we perceive as magic and explains it in a way that makes it even more wondrous and understandable. I hope you enjoyed this journey into the science of twinkling stars. If you found this explanation helpful or just fascinating, please give this video a big thumbs up. Don't forget to subscribe to the channel for more exciting science explanations and cosmic adventures, and hit that notification bell so you don't miss any of our future videos. We love hearing from you, so leave a comment below with your thoughts or any other celestial mysteries you'd like us to explore next. Thanks for watching, and keep looking up.